Next session is a presentation by Antonio Marzia, VP and General Manager, EMEA and APAC, Topcon Positioning Systems, on AG re-evolution led by technology, data, autonomy, and show how AG is ahead to the automotive industry.
Good day, everyone. My name is Antonio Marzia, and I am the General Manager for Topcon Agriculture. I want to start my speech just describing what the title of this presentation means, because basically everyone speaks about revolution. The reality, what we have seen in the last year is a step-by-step evolution, one step after the other to bring where there is a much value for the customers and the farmers. Just a few words about Topcon Agriculture. So basically, we have a full ownership of core technology from GNSS to radio communication, MU, correction services, control software, mapping, agronomic, and in addition, also hardware knowledge. We built our consoles, our displays. We have an IoT platform to manage the farmer information and extract value out of them. Let's start, looking at what was the story of precision agriculture and technology across the years. And basically, we will evaluate on time and what the technology evolution has been. So we started probably ahead of automotive industry in the 90s. With the optimization of a single machine. So when the GPS became available, obviously one of the first applications was guidance, manual guidance, supported guidance. So a way to avoid the driver stress and do very precise operation in the field. And we start also monitoring the yield from the different machines and start extracting data out of them. The second phase, it's when basically technology became more available, communication, and the evolution of the use of the GPS. We had the phase two, the one defined by improvement in the efficiency using agronomic. And this technology were exactly what gave information to the agronomist ahead of the operation. And with the feedback after the subsequent operation, there was an improvement overall of the process and the yield. Then it's the phase three, the phase where we are now, where basically all the data created through this digital and hardware tool start to become an ecosystem where different players are inside this ecosystem, and where all the information are shared to boost the support and the information and the decision making of the farmer, again, to improve the workflow and to improve the efficiency of the system. That's basically the concept that move us from a single machine with some technology to a system of machines that work together. That is no more no less what in 2014 Michael Porter pictured it this way, where we go from a single product, the product becomes smart because there is a bit of a technology from precision agriculture, becomes connected, and then all connected vehicle plays in a sort of information around the machines that work in the field to improve the overall system approach to what is called system of system, where not just the machine are cooperating, but also other information that comes from the internet, from the web, weather information, satellite information, services around data created by the machine itself. And this is also a big change because from a customer value today, without this system of system approach, we sell goods, we sell machines, we sell tractor combines, and then we sell technology. What this evolution pictured by Porter will bring to us is that at the end of this cycle is the technology selling the goods. and changing completely the mindset of the farmer, of our customer, buying and trying to optimize their farm. Then let's see what this farmer is, because at the very end, this moment, I would say, confused, because he has different inputs, different players that want to sell, want to service them with something, starting from the OEMs that are looking at this an opportunity of fidelization of the customer, and are trying also by themselves to extract information and value out of data. Let's think to maintenance services. Let's think to buying behavior, mission profiling, how the machine is used. Everything that gives a better knowledge and better opportunity to do their product better and better. Then we have the traditional technology like Topcon that basically needs to become more flexible, because again, the farmer can choose technology embedded in their machine and the technology from, again, players like Topcon. And then we have the input supplier that have always targeted the farmer directly, demonstrating the ROI of their product rather than another, and building a strong fundamental strategic approach through data management and data interpretation. And then we have a ton of non-traditional players that are entering in this business just using the data and providing the services to the same farmer. If we look in reality, what's the impact of these last category, so the newcomers, you see that there are tons. This is just a snapshot of a single region in the US, and you can see how many do we have. So it's clear that we have a difficult, a certain difficulty to understand from a farmer point of view what's really the value that these players brings to him. Then on the other side, just to look at the market, and one of the primary products that are the steering system, what's the trend in the last year? And we see that we started with manual guidance. So the simplest way to control the steering of a tractor. That means basically, you have a display in front of you, and the display tells you where to turn the wheels. This basic system has basically plateaued more than 10 years ago, and slightly reducing, as the technology was allowing premium household steering. So I control a system that was automatically and independently steering the wheel. In this last year, we saw also a huge increase of this kind of solution. Most OEM factory fitted the solution, and we are now close on bigger machine to the 80% take rate ratio. That means that we see a trend that has plateaued and remain constant in these years. What instead we see, starting from 2018, 2019, an increase of what in Topcon we call value line steering. That's basically a premium auto steering with some specific and target functionality that brings a good ratio price and performance. And we see these requests coming basically from all the emerging market, but not only, also from a specific application, for example, in orchard, vineyard. And there is a commonality in terms of performance requested and feature requested. The other trend that we are seeing, it's about autonomy. We don't know really what's going to be the adoption curve of this feature, but the reality is that everyone is working on some sort of autonomy level in their offering. And basically, as you can imagine, the future trend, the future growth of auto steering in the markets, it's basically made by three components. The classical auto steering that, as I said before, has plateaued to around 80-90% take rate. And these two product lines, I would say, that are growing pretty exponentially. So if I have to define, based on what we have seen so far, what are really the ag trends in the future, it's for sure the value line segment, mainly driven by hardware commoditization, and autonomy, based on the core technology and the use of data and digital platform. Let's speak about a value line. On the right, I just try to show how the vehicle market in agriculture is segmented. So we have the premium product, we have the mid-range. So far, precision agriculture has been looking just at these two ranges. Then we have the value line that is made of a mix of vehicle, low-cost value, specialty vehicle, tractor, and below the 100 horsepower, specialty application, value line combines. That is the market that today it's requesting something. As the technology is evolving, also those machines wants to play a role in this automatization and this technology advancement in terms of feature and opportunity. As I said before, it's led by the emerging ag markets, but in reality, as I said, there is a ton of opportunity for this. It's based also on a request on a different approach, basically the bring your own device, use your mobile, use your tablet to get the information, to control the information. And this is, by the way, the biggest portion of the market. So 50% of the market, it's based on value line vehicles with a huge potential. As we have around 1 million tractors a year in this segment. On the other side, the chart I showed before about evolution, it's based also on some specific application. And the progression from the GPS and connectivity to autonomy and the artificial intelligence optimization, it's driven by the data availability. More data, more information, more knowledge of the machine environment, the surrounding environment, and the better application of agronomy that moves, as Porter said, from a simple single phase optimization to an overall optimization of the task performed in the field. But what we need really to evolve this concept to autonomy, because most of the pieces are around and are available. We start from access and control. So basically the way through your display in the cab or bring your own device in your hands, you start controlling and planning what to do. And this is already available. What is then needed is that basically to substitute the human senses with the perception sensors. Then, add the remote monitoring. So to understand what the machine is doing and when the machine needs to operate and control the work. And this is basically what we have in most of the digital platform that capture data from the machine. Then you have the communication. And this is something, as I said, already available. What still needs to be fully deployed probably is the planning portion. And the planning portion simply because autonomy is basically a continuous replanning of your path of what the machine needs to do based on certain events. Think about a machine that is seeding with certain paths, and then at a certain point needs to decide because a storm is coming, if to accelerate the operation or to stop and wait better condition. Everything is done through a planning software, and it's one of the area that is going to be mainly developed in these future years. When you connect all these features, then you have an autonomy, because you have basically a system that automates certain operation, sense like humans, and is able to take a different decision based on the outside condition. But obviously, all of this needs to deliver customer value along all the year, along all the phases and the agronomical cycle, as I said. And differently from automotive, I would say, here the machine doesn't need just to steer, go ahead, stop, and avoid the obstacle. In agriculture, an autonomous machine, as I said before, is a system and needs to improve the system overall and has to act certain operation while steering and while avoiding obstacle, and deliver benefits on the labor side. That doesn't mean a reduction of the number of people, but boost of the human possibilities, needs to improve productivity because precise and on-time operation, and needs to deliver some agronomic value because most of these machines are acting agronomic prescription and suggestion. So you see from the different operation, the different value of what the machine it's performing. So like the harvest, where there is less agronomic value, but more productivity and more labor, to planting and spraying, because the labor reduction, it's not really the target. The customer want to see what's planted because that's the most critical operation, while productivity and agronomic value is high. Think about what I said before about the machine sensing and evaluating what to do based on the weather, and the agronomic value to have a perfect positioning of the plant inside the ground. But the very problem, the big problem we have in the future of autonomy is for sure the affordability of this solution. In this, automotive is very much helping because sensor cost continues to decline. And with the picking up of the automotive autonomy feature, the ADAS, for sure, those prices will drop dramatically. What we feel is that as a farmer, is at the end an entrepreneur, they will find affordability of the solution is if their payback is going to be less than 3 years. And then the work from everyone that is playing around autonomy is just to demonstrate that payback. But where and when to start making autonomous agriculture task? What we believe is simply that, as the title remembers, this is an evolution. The first user cases are for sure the simplest and the more repetitive. Simply because the farmer needs to know technology. They don't want to risk their crops and their yield just for the sake of using a new technology. They want to become acquainted. They want to become comfortable with the technology. So we believe that the first application are the one that delivers more value. Orchard and vineyard application, for example, mainly for safety and health reasons. Think spraying, a vineyard with in a windy day and without protection or a safe cab. Then, there are operations that the farmer doesn't like to do, and that's their first target. Think to spreading or reaping, doing tillage operation. So that's something that is boring. And as I illustrated in the previous slide, for example, they don't like planting and seeding operation completely autonomous. They want to see what happens behind. It will change for sure in the next year, but our belief is that this is the situation today. Then what I said, basically so far, it's just a sort of, evolved hardware technology, more and more sophisticated embedded software technology, and what drives everything, it's the data portion. So manage data that are collected. So what really we see is a sort of dual path in the evolution of configuration of a machine. Basically, when you start from as a single machine, you have on one side an hardware evolution. Basically, system inside the tractor of the vehicle are more and more are adding automation feature on the transmission, implement, there is an electrification and an overall improvement from an hardware point of view of the systems. Then you have another path that is the one that goes through data, that started with the telematics, the logistic, the fleet management, then the task management, what we have to do in the field, and the sharing of those information within an ecosystem. Many players have different characteristics, different features. They merge the information they have and they build an ecosystem of information. If then this ecosystem of information, it's coupled with what we know about the environment through sensing, through sensors, through information, from example of the weather, and you add, the artificial intelligence to interpret those data and give some insight or some provision on what to do. Then when all these paths merge together, we have an unmanned machine with artificial intelligence. That's the real concept of autonomy. And for example, this is also how these, what I visualized before, so how those paths merge together look like, from a feature growth point of view. What are the different steps on a harvesting machine, on a combine, or what needs to be put together? What are the information and the hardware improvement to move to an autonomous harvester? And then what said before, how this becomes a architectural ecosystem, where one side you are the vehicle is you that with all the subsystem and all the components delivers information to a core portion of the software of the machine, where basically you have communication and all the information from the outside sensor that speaks with an onboard application and an onboard hardware inside the cab, and connects with a data platform, as we picture TAP, that is the Topcon one. And all this system basically makes what we said in the previous slides. So basically, it's clear that data are key in this evolution. Hardware, it's mostly available, but the data are the one that really will create this evolution. And all the companies that want to embrace this evolution will become sooner or later terabyte companies. So basically, where the value is more on the quantity and quality of data they manage to improve the efficiency of their solution, their ecosystem architecture. Thank you very much.
Thank you, Mr. Marzia, for an informative presentation. Certainly a power-packed session with lots of learning. Now we'll proceed to the next session. Stay tuned and keep tweeting using the hashtag ETAuto FEVS.